The only transformations that will change the size of your shape is a dilation. So you might have heard the word dilate when you're thinking of your pupils dilate when they're in the light in our eyes. So dilations can change the size of the shape. They are the only transformation that changes size. We use the scale factor is how much bigger or smaller the shape is getting, and we use the letter K for scale factor. So if you ever see a problem, if it says this triangle is dilated by a scale factor of 4, you might see the words, or it might just say K equals 4. That just means the scale factor is 4. If the scale factor is greater than 1, then your figure gets bigger. And if it's less than 1, then your figure gets smaller. So if I say dilate it to a scale factor of 5, your figure will get bigger. A scale factor of 1/5 means it will get smaller. Okay, so let's practice. Let's graph. Well, they already graphed MNOP here, but what they want us to do is let's write the ordered pairs for MNOP. So M is up here at 3, 9. 3, 9. N is at 6, 0. O is at 3, 1, 2, 3, -6. And P is at -3, 0. So what dilation is every vertice, every point is going to be 1/3 of the shape is going to get a third smaller, basically. You have to focus on what your center of dilation is. For this one, the center of dilation is the origin. That means every shape, every vertice will will only be a third as far as it is now. So right now, do you see from P to the origin, it's 3 units long? Well, 3 times 1/3, because what we do is we multiply by the scale factor, is 1. So our new ordered pair is going to be right here, just 1 away from the center of dilation. And that's P prime. Let's look at N. N is 6 units away. Well, if I multiply 6 times 1/3, these cancel out, we get 2. So that means N prime will be 2 units away from the center of dilation. So what you're doing is you're making everything a third smaller. So a third of the way, it's 1/3 of the size that it used to be. Okay, so to do these ones are a little trickier. M, I like to count. M used to be 3 right and 9 up. Well, if I'm multiplying by 3, I'm essentially dividing. But I'm sorry, multiplying by 1/3 is the same thing as dividing by 3. Let's actually write that right here. Multiplying by 1/3 is the same as dividing by 3. It's much easier for our brains to think of dividing by 3. So let's divide that by 3. We used to go 3 right and 9 up. Let's cut that by 3. Now we're only going to go 1 right and 3 up. 1 right and 3 up. And I want to show you that this point right here from the origin, I'm actually going to make a line. I don't want you guys to make a line, but I want you to see it used to be, well, that's a big line. Okay, from the origin to the M used to be that long. And the new point is 1/3 of that distance. Okay, so if this used to be, for example, let's say this was 12 units long, now it's going to be 4 units long. Or like this one was 6 units long, now it's 2 units long. This one is 3 units long, now it's 1 unit long. We're cutting everything in thirds because that's what the scale factor is. O was at 3 right and 6 down. If I cut that by thirds, it'll be 1 right and 2 down. Okay, and you can see that every vertex is now a third smaller than it used to be, or a third closer to the center of dilation. Now, one way you could also do it using the numbers, and you can only do this if the center of dilation is the origin, you can actually just multiply each of these numbers here by the scale factor. So let's do that. The scale factor is 1/3, so instead of multiplying by 1/3, we're going to divide by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Do you see how if I cut these by 3, divide by 3, I'll get this? Okay, 60 divided by 3 is 20. 3 negative 6 divided by 3 is 1 negative 2. And negative 30 becomes negative 10. And that's a lot easier, but that little trick is only if the center of dilation is the origin. Let's make sure we plotted these correctly. M was at 1, 3, N was at 2, 0, O was at 1, negative 2, and P was at negative 1, 0. Perfect. So this last one here, QRS, the first thing we're going to do is plot our points here. And you always want to label them. Okay, and then it's telling us the scale factor is 2 and the origin is the center of dilation. So I want you to visualize, if the scale factor is 2, what's going to happen to this triangle? It should get twice as big. So do you see how this from R to Q used to be 2 units long? Well, hopefully if we do it right, 2 times 2 is 4. It should end up being 4 units long. Okay, so let's just multiply each of these numbers by 2. Negative 1, 0 times 2 is negative 2, 0. Negative 1, 2 times 2 is negative 2, 4. Negative 2, 1 times 2 is negative 4, 2. And let me plot these. All right, so this is what I was saying here. The original RQ was 2 units long, and now after the scale factor, it's 4 units long. That makes sense because the scale factor was 2. Now, if the scale factor was 1/2, this 2 units would have turned into 1 unit. Okay, and that is dilation.